Okay, so this time I'm going to try and do it while writing. So we'll see how that goes. So for 1.16, it tells us that we have a curvature. X is equal to a cosine theta. Y is equal to a sine theta. And z is equal to 0. So if I rewrite this in parameter ways, it's going to be written as a cosine theta I plus a sine theta j. Oops, j. Now, what we're getting to is, so I'm going to pause there for a second. So what we're getting towards is the unit tangent vector. Now, the unit tangent vector is this equation. T of theta is equal to dr d theta divided by the magnitude of dr d theta. So in this case, we need to find dr d theta. Well, here's our r. We can take the derivative of this fairly straightforwardly. So dr d theta is going to be equal to negative a sine theta I, because the derivative of cosine is negative sine, plus a cosine theta j, because again, the derivative of sine is cosine. So there's our dr d theta. So now let's find the magnitude of dr d theta. Well, to do the magnitude, you take the square of the square root of the squares. So the magnitude of dr d theta will equal a sine theta squared plus a cosine theta squared. And in this case, you'll get a squared sine squared theta plus a squared cosine squared theta. And pulling an a out, a squared out, you'll get sine squared plus cosine squared. And remember that sine squared plus cosine squared is just 1. Therefore, we have the square root of a squared, which is a, which, reminding us what that was actually finding, was the magnitude of dr d theta. So coming back up to here, if we want to write our t function, t of theta is equal to dr d theta, which was right here. So it's equal to negative a sine theta plus a cosine theta. Oh, sorry, I forgot the i's and the j's. All over a. Okay, so that's the, well, we can simplify it. So let's simplify it actually. So simplified, let me rewrite it though. T of theta is equal to negative a sine theta I plus a cosine theta j all over a. Notice that the a's all cancel. So what we're really left with is negative sine theta I plus cosine theta j. Now, what they want us to find is the unit normal vector, which is n, unit normal vector, and this weird kappa, which is known as the, it's just like a quantity, the curvature. And to do this, you need to find dt ds, where s is sort of the path length. But we don't know this exactly. So what we're going to do is rewrite this as, instead of dt ds, we're going to write it as dt d theta and d theta ds. Or sorry. We're going to write it as dt d theta times, what would be the better way to do it? Actually, I think trying to think. Okay, I won't try and explain it. I'll just use the equation they give us in the book. So in the book, they tell you that if you want to find the unit normal vector, all you need to do is this. So dt over d theta divided by dr over d theta, the magnitude. This was the equation I found in the book. So dt d theta means I have to take the derivative of this, which isn't too bad. So the derivative of this would be negative cosine. So negative cosine theta I, and then take the derivative of this part, be minus sine theta j, and then divide it by the magnitude of dr d theta, which we found on the other page was a. Therefore, the top part of this equation, this guy here, is going to represent your unit normal, your n. And this guy here, or I should say specifically, whatever you multiply by this n, whatever you multiply by this n will be considered this kappa, this curvature thing that you're looking for. So n of theta, this unit vector, is going to equal negative cosine theta I, minus the sine theta j. The kappa value is going to equal 1 over a, because in the book, let me find it here, it's equation 1.12 on page 20. They explain that dt ds is equal to kappa times the unit normal. So if the unit normal is this thing, then kappa multiplied by it must be 1 over a. That will give us this. And then the last thing I believe it asks you for is the radius of curvature. Well, we already did that. That's just the radius of curvature is just a. That's the magnitude dr d theta there. So these are like the 3 pieces of information I think that they want you to find.